Hello, I'm Dr. Harper. This video is in Management of Operations, BUSN 6630, Section 1, Spring 2021. I'm going to go over Quiz 5, which is the MRP and ABC inventory classification. But first, let's bring up Canvas. And in Canvas, in the home page, if you come down to the website, mdharper.com, the link of Operations Management, and we come down to the videos, Linear Program, Agri Planning, Inventory, MRP. These videos here, video 1, video 2, video 3, and even video 4, really these videos will more than answer the questions on MRP. And if you have any questions, you can certainly ask them during the Q&A question and answer period on Canvas. However, notice there's nothing in ABC inventory classification, so this video will cover ABC inventory classification. So let's bring up the quiz. Okay, here's the quiz. As I say, coming through here, these pretty much come right out of the video. Questions 1, 2, and 3. Now, questions 4 and 5, here where we're talking about ABC inventory classification. So let's get into this. Company B is conducting a review of their inventory policies to determine any needed changes. The annual usage and annual inventory, average inventory, were obtained for each SKU items. And let's assume this is over a year, over a fiscal year. A constant carrying cost and ordering cost were used for each SKU item to compare current strategies with optimal strategies. And they're given right here. Okay, now, in practice, usually the carrying cost, ordering cost is not necessarily the same for every SKU in your inventory. But to keep it simple, we'll keep it this way. And you can see when I start deriving this and developing this, it doesn't have to be the same. It could be any ordering cost and carrying cost. Each one can have their own. But let's get into this. So let's work this. So question 4 says, if the observed annual inventory, average inventory, which is right here, that's the observed annual inventory. If the observed annual average inventory level of a SKU item deviates either greater than or less than 50% from the optimal annual average inventory level, then action is indicated. How many SKUs are identified for action due to this criterion? 0, 1, 2, 3, or greater than 3, because there's a bunch of them here. Okay, well, let's work this, and let me show you how to work this, mainly because this is a very practical problem. Okay, so let's bring up Excel, and notice what I've done here. In this Excel, I've already typed in a template here, and this is what we'll be using. But on the optimal inventory here and the optimal frequency here, I have some equations in here, and these equations came from this development. Well, first of all, it came from this equation here. If we go back to the lecture notes in ABC classification here, we come down here when we did the optimal frequency. This is the equation I'm looking at. Okay, I'm pulling this equation from the notes and basing our optimal inventory policy and inventory based on this optimal frequency. Okay, that's what this number is here. So let's look at this derivation a little bit. Okay, this is the frequency is a square root of the usage. Remember, the usage down here is same as demand, times 2, divided by 2 times the number in the class, times EPP, where EPP equals the ordering cost over the carrying cost. There's EPP. Okay, so the optimal inventory is going to be, well, I have this equation here, but I'm deriving it right here. So the average inventory, follow this logic, the average inventory is Q over 2. Let me just highlight all this. The average inventory is Q over 2. Q from the fundamental equation is D over F over 2. But D, the demand in dollars in the ABC classification, I've labeled M. So it's M over 2F. So bringing the 2 inside the parenthesis. So F, though, bringing this equation down here, F is the square root of M over 2N EPP. But N here is 1, because we're going to do this for each SKU item, not a class, each SKU item. If N equals 1, then this becomes M over 2 times the square root of M over 2 times EPP, where N is just 1. I collect terms, and I have the square root of M times EPP over 2. So I bring the EPP up, I bring the M inside the radical, and then I have M times EPP, and the 2 in here would be 4 in the denominator, 2 in the numerator, so it's over 2. Now the optimal frequency is M over 2 times the average inventory. Okay, well, deriving that now. Well, I have the frequency equals, from the fundamental equation, D over Q. D is the same as M. M is the dollars usage, which is the same as demand, over Q. Okay, I can divide the numerator by 2 and denominator by 2, and that's identity. Q over 2 is average inventory. The numerator is M over 2. Collecting terms, I have M over 2 times average inventory. So there's my optimal frequency. So from these equations, I can get what the optimal, when I have my usage and EPP, I can get my optimal inventory, I can get my optimal frequency, compare that with my observed inventory and my observed frequency. So let's bring them in. Well, first of all, we have our ordering and carrying cost here. Let's see what our, from the problem here, our carrying cost is 64 cents per dollar per year. The ordering cost is $80 per order. Okay. Ordering cost is 80. This is 0.64. And so this is just the ratio of ordering cost to carrying cost. And we got 125. So let me bring this down here, equals 125. Let me just copy it in my table, because I'm going to be using this. I will definitely use this all the way down to here. Okay. Oops. Let me do it this way. There we go. Copy this down all the way down. There we go. That's all 125. Now the SKU, the usage observed inventory, that's going to come from the problem. So let's take all of these, Control C, come over here, and bring this down a little bit so we can see it, and put it in. All the way down to here, Control V, and there it is. And then post the values. And there's our values. So first, let's get the optimal inventory and take the index. Because remember, the question says, which is a very practical question to manage your inventory, if the observed annual inventory, which is given here, of a SKU deviates either greater than or less than 50% from the optimal average inventory level, and the optimal average inventory level is given by this right here, right? Then action is indicated. So let's get the observed and the optimal. Okay, here's the observed. Let's get the optimal inventory level. Well, I bring this equation down, this equation right here. Okay, and let's just calculate it. Equals the square root of M times EPP 125 divided by 2. And there's your optimal inventory based on the usage in EPP. And let me copy that down. And there we go. Okay, now let's just take a ratio here, equals inventory 1 divided by inventory 2. Okay, and this is, the difference is 35%, okay? And then let's copy this down, all the way down. So there's my ratio, okay? And so it's like an index, one relative to the other. It really doesn't matter because I want 50% deviation greater than or lower than. So that's going to equal the absolute value. I don't care if it's more or less. All I care if it is more than 50% than 1, okay? So it's 1 minus my index. And so if that's greater than or less than 50%, then it'll tell me. And let's just copy this down. Okay, we know it's not 0. So what we want to do is just increase these things to where we actually see what's going on here. And there they are. Okay, let's see here. Does this look right? Good. Okay, and there they are. So now the question is, so here's the deviation. So I want to flag these if they're greater than 50%. Well, the way I do that is pretty easy. If this number right here is greater than 50%, well, I put 50 up here. Oh, I tell you what, let's do. I have a better idea. Let's come to here and let's multiply this by 100. So now this is 35%. So these are not decimals, these are actually numbers, percentages. Now let me just put a 50% in here. So this is going to equal, if this number is greater than 50%, I could have left that a decimal, and I could have put that 0.5. But since the problem said 50%, let's use percentages here. If it's greater than that, then I want to designate it as, I want to flag it. Let me say, is it greater than? I'll say yes. Otherwise, if that's not true, I'll just leave a blank. Okay, and I think that let's see if that works. Let's just copy this down all the way down to there. Let's see what happened here. Oh, I need to fix this. Let's do this again. This K through 18, it's changing on me. I go F4 to fix it. Okay, and then I copy it down. Because I can see some of these are more. Yes and yes. So let's see, there's 2 of them. There's 2 of them. And so over here, when you look at this, is how many are identified for action. Well, 2 were flagged. Okay, so we know that question. And then the other question is, what is a possible annual total inventory cost savings, which is the ordering and carrying cost, from the current inventory policies relative to the optimal inventory policies, run it to the nearest dollar. Okay, let's see here. Well, we have our inventory here, and down here our sum. Let's take the sum here. I keep going up and down. Let me just take all of these. The sum of the observed is there. Okay. Let me bring this down so we can actually see it and not keep going up and down. Okay. And then the sum of the observed, or the optimal. Let me sum the optimal. So here is the inventory, the optimal, and here's the sum of the observed. Okay, and so let's take the unit cost here, which is equal to 0.64. Whoops, 0.64. Okay, and this is equal to 0.64. And then multiply. Okay, so now we have these 2 costs. And so now let's, actually we can bring these up if we want to. I have this total cost over here. Okay, so the observed inventory cost is going to equal, well, let's see what it is down here. The observed inventory cost is equal to that. Good. And the optimal inventory cost is equal to this right over here. Here's my optimal right there. Boom. Okay. And then the difference. So let me just let me say the difference equals the I just want the difference. Let me just equal the absolute value of these, of this minus this, so it doesn't matter what order we have. So that's going to be the difference. Okay, and I can reduce these down to only 2 decimal. We want just to $1. So there we go. Now we need the ordering cost over here. We need the frequency. Okay, now I'm going to use this equation here, actually for both, m over 2 times the inventory. Okay, so for the for this one, for the observed, this is going to equal m for the observed. Here's m divided by, open parenthesis, 2 times my inventory for my observed, which is that right there. Okay, and then for my optimal, same thing, m, my usage, demand same for each, divided by, open parenthesis, 2 times my optimal inventory right here. Okay, because demand over D over Q equals F. Okay, return. So now let's just take this and just copy this down. All the way down. And there they go. And now let's sum them. These right here. And then the unit cost is going to equal 80. Equal 80. Bring this sum over. Multiply. Oops. Equals this times this. Bring this over. And now we have the two values. We can bring these up. The observed ordering cost equals observed frequency is going to be that. The optimal ordering cost equals, for the optimal frequency, the cost is going to be that. Okay, and notice these are relatively the same. If I bring these down, they are the same. Why? It's EOQ. Then the difference, again, let's take the absolute value of the difference here. This minus this, and bring this down to the dollars, to the nearest dollar. There we go. Now, what is being asked is the total. That equals this plus this. Bring this over. And then the difference here is what's being asked for. Okay. And so I'll bring this down to the dollars too. Here we go. So that's going to be, let's bold that, box this in. And so these right here, box this in and bold these. So this is the answer to question 4. That's the answer to question 5. Okay, and so that's how you work this this problem. And so before I leave, let me just point out that when you know these unit costs, then you can monitor your inventory. You can do this automatically. You can flag these things. And do you have to look at all 1,000? No, just flag the ones that are problems. When you flag them, now you know which ones to look for, which ones are too much or too little. And so how do you know? Well, this one right here has an index of less than 1. This has an index of much greater than 1. So what we have here is that we know that the inventory here, the inventory is much less than what it should be. And this inventory is much more than what it should be, okay, because of the indexes. And so another thing you could do is simply take these SKU numbers. Let me go ahead and take all of this. Let's go ahead and take all of this, okay, and then I can sort it on the indexes. Okay, I want I here. I can go to data. I can do sort. I don't have headers. So it's going to be column I from, let me have largest to smallest. Sort those things. I need to copy this and then post it as values. And now I can sort it. Largest to smallest, and there it is. And now I have a Pareto analysis of the highest SKUs here. Okay, there they go. There's the highest ones where the observed inventory is greater than the optimal inventory. I'm carrying too much inventory. At the bottom, I have the observed inventory is much less than the optimal inventory. I'm not carrying enough inventory. I'm ordering too many times. Okay, so right up here we have excess warehouse cost. Down here we have excess purchasing cost. And so we can work our way toward the middle. Okay, well, that's all I have for the homework here, Quiz 5, MRP and ABC. I hope this helps. And between now and the next time I see you, I just want to urge everyone to be safe. Don't take anything for granted. Stay healthy. Keep learning. And between now and the next time I see you, if you have any questions, go to Q&A. But between now and then,